Today we're going to be solving quadratics by factoring. So we're going to take what we've been working on with factoring and we're going to take an extra step of setting our factors equal to 0. You'll see each one of these is equal to 0 because instead of setting it equal to y, we're setting it equal to 0. Remember, we do this when we're trying to find our x-intercepts. So we're going to be finding where our graph crosses the x-axis, our x-intercepts, by replacing y with a 0 to find our x-intercepts. So we're going to be factoring just like normal, and then once we find our factors, we're going to set those factors equal to 0 and solve to find where it crosses the x-axis. So we're going to start off with a pretty simple one where we're just able to factor using our GCF method. So I'm going to go ahead and put my polynomial inside the house, or my quadratic inside the house. And then I'm going to go ahead and divide out my common factors. 4 can go into both, so I'm going to divide out a 4 first. And x can also go into both, so I'm going to divide out an x. And just like normal, we're going to write this as the product of two factors. So we're going to have 4x times x minus 3. And we're going to set each one of those equal to 0. So I'm going to have 4x equals 0 and x minus 3 equals to 0. And once we do this, we're going to have our x-intercepts. So I'm going to go ahead and solve the first equation. X is being multiplied by 4, so I'm going to divide by 4 on both sides to get that multiplication to cancel out. And 0 divided by anything is always just going to give me 0. And then on this right-hand side, on the second factor, x is being minus by 3, so we're going to add 3 to both sides and get the subtraction to cancel. And our second factor would be 3. So those are our two x-intercepts. Our graph crosses the x-axis at the value x equals 0 and also at the value x equals 3. So go ahead and try that second problem for factoring out the GCF and enter into the formative. The next example we're going to take a look at is if we have a difference of squares. So when we have a difference of squares, remember to factor that. We're going to take the square root of the first term and the square root of the second term. We're going to have a plus and a minus. The square root of x squared is x, and the square root of 49 is 7. So we're going to take each one of those factors and set equal to 0, just like we did in the previous example, so that we can find our x-intercepts. And in that first set, we're going to subtract 7 from both sides because it was being added to cancel it out. So our first x-intercept is at -7. In our second set, we're going to add 7 to both sides because it was being subtracted. And our second x-intercept is going to be at +7. So those are the two places on the x-axis where our parabola crosses. You guys go ahead and try that second problem for you try and enter into the formative. So now we're going to take a look at what happens if we have a quadratic trinomial. So remember, those are going to be in the format ax squared plus bx plus c. And a, b, and c are just numbers that are going to be in each equation next to the x squared term and the x in our constant. So here we have a little bit of a different step. When we have a quadratic trinomial, each of them have 3 terms because it's a trinomial, and we have a second degree as our leading term. So our first step is going to be to multiply the value of a and c together. Then we're going to list the factors of that number, and then we're going to choose the factors that we're going to use to solve for our x-intercepts by choosing the factors that multiply to get c, our last term, and that add together to get b. There is a special case if our a is not equal to 1. So this second example we're going to do, it has a 2 in front of the x squared instead of nothing. So our our a value here is 2. So if that happens, then we're going to rewrite the quadratic with the new x terms and factor by grouping. So if we have a term out front or a number out front of x squared that is not 1, we are going to have to factor by grouping before we solve. And once we get our factors set, then we're going to set them equal to 0 just like we did above, and we're going to solve for x. So we're going to take a look at this first one where we have our a value. Since there isn't one written, our a value is 1 and our c value is 8. So our first step there is to multiply a times c. So we've got 1 times 8, and that gives us 8. Our second step is to list the factors of 8. So we've got 1 times 8, and we've got 2 times 4. Those are the only ways that we can get 8 when we multiply. And step 3, we're going to choose the factors that multiply to give me 8 and that add together to give me 6. So we know that both of those multiply together to give me 8. But now we're going to choose the factors that add together to give me this positive 6. 1 plus 8 gives me 9, so I'm not going to use that one. 2 plus 4 gives me 6, so those are the two factors we're going to use. And then step 4, we're going to set up our factors. It's a positive 2, so we're going to say plus, and it's a positive 4, so we're going to say plus. We're going to set those equal to 0, and just like before, we're going to set each individual factor equal to 0 and solve for x. So on this first one, we're going to minus 2 from both sides to get that to cancel out, and we get our first x-intercept is at x equals negative 2. And in our second factor, we're going to minus 4 from both sides and get that our second x-intercept is at x equals negative 4. Okay, so that's if our a value is 1. It's a little bit more simple. But moving over to our second example where our a value is a number other than 1. So this is a little bit different. We're still going to start off the same way. We're going to multiply our a value times our c value. And when we do that for this one, we get 42. And then we're still going to list the factors of that product. So to be able to get 42 when I multiply, I can say 1 times 42. I can say 2 times 21. I can say 3 times 4. Sorry, not 3 times 4. 3 times 14. Or I could say 6 times 7. Those are the factors, how I can get a product of 42. So now I'm going to go through on my step 3, and I'm going to choose the factor that's going to add together to give me my b term. So I need this to add together to give me negative 17. So when I add together 1 and 42, I get 43. So that's not equal to 17. 2 plus 21 gives me 23. So that's not equal to 17. 3 plus 14 does give me 17, and 6 plus 7 gives me 13, so that doesn't equal 17 either. So now that we have that picked out, it does need to add to 17, but we have a negative right here. So instead of positive 3 and 14, we're going to have negative 3 and negative 14. And then we're going to go ahead and do our special step here because our value for a is not 1. We're going to rewrite that polynomial, and instead of minus 17x, we're going to replace that with the minus 3x and the minus 14x. And then we're going to go ahead and factor by grouping. So I'm going to put together the factors that have common factors. So our 2x squared and our 14x. I'm going to group those two together, and then I'm also going to group together my minus 3x and my 21. Okay, so I'm going to go ahead and factor those. I can pull out a 2 here, and I can also pull out an x. And then I'm still going to rewrite those as a product of two factors. And then over on the right side, I'm going to pull out a negative 3 first. And that's going to be our factors there. And then I'm going to go ahead and write out my factor. So remember, I'm going to take my GCFs as one factor and then my leftover expressions as my second factor. So my first factor is 2x minus 3, and my second factor is x minus 7. And I'm still going to set those equal to 0, so I'm going to have 2x minus 3 equals 0, and x minus 7 equals 0. And then I'm going to go ahead and solve those just like we did before. I'm going to add 3 to both sides first and get 2x is equal to 3. And then I'm going to divide by 2 on both sides and get that x is equal to 1 1/2. So that's our first x-intercept. And then on our second factor, I'm going to add 7 to both sides. And our second x-intercept is going to be at positive 7. So same steps as before. The only thing that's different if we have a number other than 1 here is that we're going to have to factor by grouping instead of being able to just go ahead and set them equal to 0. So make sure you've tried out those problems on your formative and let me know if you guys have any questions.